All right, here we are going to look at pulling those key features or those points from the formulas or equations. So we have three forms for a quadratic. The first is standard form, which should look much like expressions when we simplify and we say they're in standard form. It is from highest exponent to least. Notice that x squared comes first, the just an x term is second, and the constant is third. So it is in that standard form. From there, whatever the coefficient is to x squared is going to be referred to as a. Whatever the coefficient is to b, or to x, is going to be referred to as b. And whatever your constant is going to be referred to as c. We call this a constant. Now, our constant we're already familiar with, much like a linear function. The constant is our y-intercept. In this case, our ordered pair is going to end up being 0, c, because as we've already discussed, when you have a y-intercept, x is 0. The next thing that we want to focus on is this a value. And a can tell us something about our equation. If a is a positive number, then we know that the graph or the parabola opens up. It's going to look a little something like this. If that parabola opens up, we know that it has a minimum. If a is negative, so any negative number, we know that our graph, our parabola, is going to open down, which means it looks a little something like this, and it has a maximum for its vertex. So that min or max is its vertex. That tells you something about your vertex. If we slide over and we look at this example, I would want to be able to pull out those key features from the given example. First thing, let's practice identifying A, B, and C. We know that A here is 1. If there's not a number there, X does not equal 1, but it has a coefficient of 1. B is -6. A sign in front of a term always stays with that term. And C is 5. If we know our C value, that's our constant, which tells us that our y-intercept is 0, 5. That point is our y-intercept. The next thing we can know, hey, we know A. A is positive because it is a positive 1. So we know our graph is going to open up. It is going to be an open up parabola, meaning it has no maximum because it'll keep going up forever, but it does have a minimum. Our vertex is a minimum, is a key thing to keep in mind. Next, we're going to look at factored form. And that should ring a bell because we just spent a whole unit practicing factoring. And this is what we are going to use factoring for. It's going to be able to find the x-intercepts of a quadratic function. If we look here, it's already set up as the factored form. These two sets of parentheses as well as the a value, these are our factors. These are our factors. Now, most commonly when I'm talking about a factor, I would probably say, okay, we have our first factor and our second factor. A is also a factor, but as it doesn't have an x value, it is not going to give you a intercept. So we have our two factors. To find those x-intercepts, what you're going to do is you're going to set each factor equal to 0. And solve. I'm going to write that out as a word. Equal So we want to set each factor equal to 0 and solve. What that's going to look like here is we would have x minus m equals 0 and x minus n equals 0. I'm going to use my inverse operations, and we solve, and we get x equals m representing one x-intercept here, and x equals n representing our second x-intercept here. So whatever the number is you get there, those are going to be your x-intercepts. We had a great question in class of why do we set it equal to 0? Well, if we think about a graph, and you were talking about that x-axis, any point on this axis is going to have a y value of 0. So when you're setting these equal to 0, it would be like replacing the y with a 0 and saying, okay, hey, if I want these to equal 0, these two things that are multiplying, well, if one of them equals 0, I could be able to find the other one. In which case, we're setting it equal 0 to solve for that missing x value or that unknown x value. Now, we also still know that A is telling us if it opens up or down. For the sake of time, I'm just going to copy that information because it is the exact same. Today in class, we wrote it 3 times. If we went over it 3 times, it probably tells you that it's important. It tells us a key feature about our graph, and it's going to tell us every time. For our example over here, we should see that, hey, I have no number out front. It must be positive. There's not a negative sign. So A is positive. We know it opens up. All of our examples are going to open up because all 3 of these represent that function that we graphed on the front. I wanted you to be able to see all of the information for one function so that we could tie it together, and then we will practice with some other functions. The next thing that we need to think about is setting each factor equal to 0. So I'm going to say x minus 1 equals 0. I'd add 1 to both sides. Oops, not 0. 1, excuse me. And then x minus 5 equals 0. I'd add 5 to both sides. And I'd get x equals 5. So what this tells us is our x-intercepts are the points 1, 0 and 5, 0. To have a little mini lesson, I didn't do this in class, but I want you to see where this x minus 1 times x minus 5 came from. If I took that original equation from the front, where we looked at y equals x squared minus 6x plus 5, and I factored it. I just want to factor this. A times c, so 1 times 5 is 5. What are your factors of 5? 1 and 5, that add to be negative 6. Well, they must be negative. So I would rewrite this as x squared minus 1x minus 6x plus, or excuse me, not minus 6x, minus 5x plus 5. I'm going to take the GCF out of each group. X times x minus 1. The GCF of my second group is going to be negative 5 because it leads with a negative, so we factor the negative out. So I have x minus 1. That leaves me with x minus 1 times x minus 5. So that's where those two factors came from. You can take your standard form and get your factored form to find your x-intercepts. And that's going to be one of our goals, is we want to be able to do that. We're also going to want to be able to distribute to go from factored form back to standard form so that we know what our y-intercept is, or we're able to find our y-intercept. All right, that takes us to our last form, vertex form. For what vertex form tells us, I'm sure you can assume it tells us our vertex. But what about it tells us our vertex? Well, we see some new letters here. We have H and K. And when we have H and K together, H, comma, K is the vertex, or represents your vertex. H is going to be the x value of your vertex. K is going to represent the y value of the vertex. Together, they make the vertex. Now, we also want to notice that in the equation, h has this negative sign in front of it. So when you're pulling h value and the k value out of your equation, make yourself a note that h is opposite of how it appears in the equation. H is opposite of how it appears in the equation. Much like our other two forms, this one also tells us A, so we know that A tells us if it opens up or down. I'm just going to drag it down, leave myself that information. So if A is positive, it opens up. If A is negative, it opens down. This also tells us something else about our vertex, because a vertex is either classified as a max or a min, so those connect back together in knowing that it is either a maximum or a minimum. If I look at the vertex form here for this specific problem, I would want to be able to say, all right, looking at this form, what is H? Well, H is the opposite of what we see. Well, it looks like -3, so it must be +3. K is the same. It looks like -4, it must be -4. The vertex is 3, -4. If you look back to the front side, that is the vertex that we graphed earlier. Yet again, A is equal to 1, so this graph is going to open up, and we have that minimum for our vertex. Now, the only key feature that we haven't yet talked about on this back side is the axis of symmetry. And we can find the axis of symmetry in two forms. You can find it in vertex form, because if you know your vertex, whatever the x value is, x equals 3, is your axis of symmetry. To leave ourselves a general note, x equals h is the axis of symmetry. Whatever your x value is, that equation is going to be the axis of symmetry. The other place we could find an axis of symmetry is using a little mini formula that we wrote on the front when we talked about axis of symmetry, but you have to have standard form to fill it out. So that formula was x equals -b, or opposite b, over 2a. So if I want to use it on this one, I would say x equals negative, my b value is -6, over 2 times 1. -6 gives me a +6. +6 over 2 gives me 3. Well, that matches up. I know my axis of symmetry is 3. That axis of symmetry is 3. So that would be finding all of our general information. If we wanted to test it out on these equations down at the bottom, we notice that first, that is factored form. We are looking at those two factors. When we have factored form, we can find the x-intercepts. To do that, we would set each factor equal to 0. And we know that our x-intercepts are going to be 3, 0, and -7, 0. We also know that this parabola is going to open up because a is equal to 1. if we look at our next example here, well, this is in standard form. It takes the form of ax squared plus bx plus c, which means we should be able to tell the y-intercept right off the bat. And we can do just a little bit of work to get that axis of symmetry. So if we're finding the y-intercept, all we have to do is say, hey, what is the constant? Well, c equals -7. So the y-intercept must be -7. Oops, 0, -7, not -7, 0. From there, we would also say, hey, I can use that little mini formula, -b over 2a. So I would have -4 over 2 times 2. -4 over 4, I get -1. So my axis of symmetry for this equation must be x equals -1. Finally, a is +2, so this opens up because a is positive. Our last form would be that vertex form. You've probably already realized it, but vertex form is characterized by that binomial being squared. So we have that x minus 5 being squared, which tells us we're looking at vertex form. The first thing I would want to do is identify h and k, because this is going to tell me my vertex. I know h is the opposite of what it appears, so it is 5. K is the same, so it is 8. So my vertex is 5, 8. If you have your vertex, you can very easily make that hop, skip, and a jump, and we get x equals 5 is the axis of symmetry. Finally, we can tell our a value. A is -4 here. So we know that this parabola or this quadratic function opens down. We're going to explore a little bit further and see what the different specific values for a do. As far as does it make it wider or narrower. We're going to give names to those types of transformations. So we'll use some of our vocabulary from our last unit for transformations, but we should be able to identify those. So the goal here would be able to identify the key features from any of those forms. There is a question on your 10.1 homework that specifically focuses on this. You want to be able to look at the equation and say, hey, what form is this? And where do I find that? Another pattern you may or may not have seen is whatever numbers have in here have ended up so far being our x, the opposite of those were being our x-intercepts. That is perfect. If you want to see this and say it's the opposite, except for when it ends up with factors such as these. -2x minus 3 times 5x plus 7. In this case, when we set these equal to 0 to solve, notice it's not just going to be 3, because we'd still have to come back and divide by the 2. So our x-intercept is going to be 3/2. Same thing with that 5x plus 7. It's not going to just be -7, because when you come back, you've got to divide by that 5. And we have x equals -7/5. That would just be an example of where it's not just the opposite. However, that is a two-separate equation that you can probably solve in your head. And you're absolutely welcome to do that. You don't have to write out that step. However, writing out that step does keep your work clear and easy to find.